Welcome, everybody. Today we are going to play bingo. We want to play buzzword bingo because we are going to make sense of AI-ready APIs in our current buzzword world. Because we want to see how APIs can become ready for AI consumption. Before we start into that, let me quickly introduce myself. My name is Andreas. I'm an IT architect and developer working at Pentacor, and I'm also a nerd, which means I like to dive into all kinds of tech topics, regardless of whether they are directly related to my daily work or beyond that. And in that sense, I'm working with AI topics and also in the field of APIs. And while we're here talking, AI is doing its thing. We have ChatGPT that might be guessing your endpoints. We have Claude that scans APIs for open API specs maybe. And there are also 5,000 or more MCP servers that attempt to connect AI systems with other tools and also with your APIs. That means online shopping might not take place via your web shops anymore. Instead, AI agents go shopping on behalf of users. Chatbots take care of user requests, and Copilot maybe structures your workday. That means AI is all around, and the AI revolution isn't coming, it's already here. So we should briefly recap what is an AI agent. It, first of all, is an IT system that perceives and processes information. It collects data, analyzes it, and draws conclusions from it. It can act autonomously, so it makes decisions, performs actions on its own. That could be calling API endpoints, it can write code or connect tools, and in that it acts in a goal-oriented way and is adaptive. So it works towards defined goals, learns from feedback, and adapts its behavior over time. Typical capabilities could be researching information or summarizing that information, making decisions based on rules or given the defined goals, and it could communicate with humans or other systems, and it can remember prior interactions and conversations, and in the end, it acts on its own. With that, we set the stage and can now start our bingo game. Here's your bingo sheet. By the end of this presentation, you hopefully crossed all of them. And we are going to start off with revisiting some classics that have been around for a long time already. In particular, we are going to address three different topics. We are going to start off with OpenAPI that provides structured descriptions for our APIs. We will take a brief look at HateOS for navigable semantics. And we are also going to revisit APIs.json as an option for machine discovery. Let's start with OpenAPI. We can use our well-known OpenAPI documents to make our APIs AI ready. Since we're at an API conference, we don't need to go into all the OpenAPI details, but I want to point out two examples to emphasize the value of OpenAPI when it comes to making APIs AI ready. On the left side, we see a snippet that is maybe not that good for AI to understand. We have a get users operation without any additional users. And if an AI system wanted to use that, it had to do a lot of guesswork. On the other hand, we have an example that is much better suited for AI consumption. We have a search customers operation that also has a meaningful ID. So it could be combined with function calling in an AI system. And it has a summary that tells the user what actually can be done with this endpoint. And the description even includes examples for queries that could use this endpoint. And the parameter descriptions even includes further information about the way the parameter is working, and an example illustrates how input for that operation might look. And with that, an AI system, an agent, has a much better starting point to use that API, so there's not that much guessing required. Instead, natural language processing capabilities could be used to process that spec and make use of it. Beyond that, OpenAPI 3.1 also by now has full JSON schema support. And with that, we can also define validation rules to further guide machines when it comes to understanding an API. The next thing that we want to revisit is HateORS, which is the hypermedia as the engine of application state. This example here shows HAL, the hypertext application language, and the HateORS principle is intended for API discovery. It tells the consumer, the client of an API, which other actions or which other resources can be accessed starting from the current response. As we see in this example, we got information about an account, and we know that there are other options possible. So we could transfer money to another account, or we could get information about statements of that account that we just accessed. But that was intended for smart clients, although they never really came to life so far. But that might be changing with AI nowadays. Nevertheless, HateOS has some limitations. First of all, there is no information about the HTTP methods that would have to be used to get the information. If we want to transfer money, do you do a GET request or a POST request? What parameter schemas do the resources use? What data do we need to send? We don't know. And once again, AI has to guess the interaction pattern to make use of the information that were included in the response. So potentially much better option is, again, OpenAPI with the link objects. Link objects are a way to reference follow-up operations in the response of an operation. There you can directly reference another operation by its operation ID, and you can map response fields to parameters in the other operation, so that the operations are linked to each other, and we can benefit from the full context of the OpenAPI specification with all its operation descriptions. So we have explicit information about the HTTP methods, we know about the parameter mapping, we know about the schema validation that might be used, and we have the full operation context as it is specified in the API documentation. And with that, we get the HateOS philosophy combined with the structure of OpenAPI, which leads to AI-ready navigation. Last but not least, in this part, we take a look at APIs.json for AI discovery. APIs.json is the sitemap XML for APIs. It can look like this. It's a JSON document that acts as an inventory of all the APIs of a company. And in that JSON, we also have links to other resources, like the OpenAPI document. Further documentation, we can reference a Postman collection, JSON schema, or even OpenAI plugin manifests. And in addition to that, also link to other resources like a sign-up page, a login page. And with that, we get a few benefits like automatic API discovery. We can access rich metadata, and we have a standardized format and even include AI native support. The interesting thing about APIs.json is that it's actually quite old. The initiative surrounding APIs.json started in 2014, but for a long time it fell asleep and there were no further updates. It just showed new activity in late 2024. And maybe with the rise of AI, it might become relevant once again and maybe has its breakthrough now. And with that, we are going to move on to the new things that are emerging. There are three standards or protocols that we want to take a look at here. First of all, we want to talk about MCP, which grants AI systems access to data and tools. So it is the missing link between AI and your systems. We want to take a look at Arazo workflows that provide the recipes for using APIs, not just the ingredients. And last but not least, we take a look of A2A and ACP as agent protocols that allow agents to collaborate. So let's get started with MCP. The Model Context Protocol was published by Anthropic in November 2024, and it is sort of the USB-C for AI. It uses a client-server architecture with MCP clients, MCP servers, and a host. And the MCP servers act as the bridge between other data sources or other services and make them available for the MCP client on the host. And the clients could be applications like Claude Desktop or Cursor, GitHub Copilot. They all have MCP support. Or you could use that via the API, also with OpenAI. And with MCP, you have one server that works with different AI models and clients, and that model gets access to all kinds of tools and data or APIs. So it allows for future-proof integrations, forms a growing ecosystem, but it's still evolving and production patterns still have to mature. For instance, there are some challenges related to security, and transport is not completely sorted out yet. So there are different versions, standard input, output, server-sent events, or HTTP. So there's really a lot going on with MCP. So not all clients are supporting MCP yet. For instance, I'm still waiting for MCP support in ChatGPT Desktop. But nevertheless, as already said, we have already more than 5,000 servers. And MCP came to end the AI plugin hell because with an MCP server, you build something once and can use that with any AI system, and your API that has an associated MCP server can suddenly be used using natural language, which is definitely a big step forward, also makes it more approachable. Next thing is Arazo, the API workflow specification, which is the recipe book for API workflows. Arazo is another specification standard of the OpenAPI initiative, so it looks quite similar to the OpenAPI specification as well. Arazo provides quite a few benefits because let's remember that AI systems need explicit information so that they do not have to guess based on their training data, and Arazo provides exactly that. We get a deterministic description of workflows instead of the AI guesswork, and we can document business processes for humans and machines. And Arazo acts as a standardized workflow description format and removes the ambiguity from complex integrations. What that means is that you can represent complex workflows as an Arazo workflow and then can just trigger that workflow rather than calling all the API operations that are part of that workflow individually. And you can let AI do the same. So you can focus on executing that workflow than executing all the steps that form the workflow. Because if you did that instead, there is a high chance of AI systems taking a wrong turn here and there, and your workflow is not executed as it should be. And that is certainly not what you want, because agents are taking over. And with agents, the human in the loop might not be that present anymore. The agent protocols allow AI agents to work together. They can collaborate. And there are currently at least two protocols that came to life quite recently, two famous ones. The first is A2A, the agent-to-agent protocol from Google, that uses structured agent cards, which are JSON documents that are published at a well-known location and describe what the agent can do. And you can interact with the agents via A2A using JSON RPC. And agents that use A2A communicate in a task-oriented way using push notifications, server-sent events, or streaming. And on the other hand, you have ACP, the Agent Communication Protocol, that was published by IBM Research, actually a bit earlier than A2A even. ACP was introduced in March this year and A2A in April. And ACP uses agent manifests as offline metadata that are part of the deployment packages. And it uses REST-based interactions, and with that is more approachable for developers using local deployments. And in contrast to A2A, ACP uses natural language communication. So agents are just chatting to each other. And with that, you have A2A as a structured and task-centric approach for agent communication. And on the other hand, we have the pragmatic REST native agent communication powered by the Agent Communication Protocol, ACP. With that, we crossed everything. Bingo. And it's time to put everything together. So let's step a step back and take a look at our user that is using a system. First of all, we have an open API spec that statically specifies an API. Part of that API could also be the HATOAS principle that enables dynamic interaction. And if you apply APIs JSON for metadata, you have something that acts as a resource and API index. As we just talked about, Arazo extends the API specs by defining API operations that form a workflow as a whole, so that you have a definition of a business workflow that can be executed. Meanwhile, AIs and large language models appear on the stage to support the user, and that brought a challenge to provide a connection between tools, APIs, and the LLMs. So here we have MCP that makes data and tools accessible to the AI models, and it initiates interaction with APIs, workflows, tools, it accesses data whatsoever. And last but not least, we have AI agents that assist the user and autonomously use tools, for instance, using MCP. With that, we actually are talking about two different topics. On the one hand, on the right side of the slide, we have the API space, and on the left side, we have the AI space. And MCP is somewhat in both. To come to an end, let's take a look at some takeaways. First of all, there is some paradox with AI-ready APIs, because it's all about descriptive, explicit information. And the more autonomous our consumers become, the more explicit our descriptions need to be. But also humans benefit from descriptive information and explicit information. That means the better your AI documentation, also your human interaction becomes better. Which means the best AI-ready API is one that's still great for humans. And I don't want you to leave the talk without some mission. Here it is. Make your APIs future-proof and start with what you have, enhance your existing open API. Next, take a look at the discoverability challenge and maybe add APIs JSON, maybe add the HOS principle to allow for dynamic request chains, and think about workflows. Take a look at the tasks your APIs support and set up other workflows to define them as a whole and prepare for agents. Make use of MCP, take a look at A2A and ACP when they're really production ready, and experiment with that.